4, the chain rule. So I draw a chain over here. The chain rule is related to a chain.
So first, we talk about duality. If y is equal to f of x, then dy dx is f prime of x. Okay, so those two represent duality. Remember duality for graph, you can think about it as the slope of the graph. Okay, and if the function f is a position function, then f prime of x is the velocity function, and the duality. This represents any rate of change. Okay, so we think about duality as rate of change. So, for example, velocity is the rate of change of the position with respect to time. Okay, so duality, think about it as rate of change. Okay, so now we have y here is a function of u. Okay, u is a function of x. Suppose u change 2 times as fast as x, and y change 3 times as fast as u. So y change how many times as fast as x? Can someone answer this? Now, okay, let me go back a little bit. Okay, so over here, y change 3 times as fast as u. So the rate of change of y with respect to u, which is dy du, will be 3. Okay, so we have 3 over here. And u change 2 times as fast as x, then the rate of change of u with respect to x, which is du dx, is going to be 2 over here. So we have 2 over here. Now, from here, can you tell me y change how many times as fast as x over here?
6.
6, right? So the rate of change of y with respect to x here will be 6. So we have 6 over here.
I almost want to say 5.
Well, this is how many times as fast, right? So this is 2 times as fast as this. This is 3 times as fast as this. So you multiply them. Okay, so you multiply this two. So over here, dy dx is equal to this dy du times du dx. Okay. Well, it's kind of like a chain over here. So you think about this as the first ring of the chain. And this one here is the second ring of the chain right here. So it's like the two ring of chain connect together. And as you see here, if you think about it like a quotient, you can think about that the du here divide out and give you back the dy dx over here, right? So you get back the dy dx. So kind of like a chain right here. The chain here can get longer. So if you have this relation right here, then dy dx is dy du times du dv times dv dx. So the chain can get longer. In this case, you can get 3 rings over here. Okay. Okay. Now another notation for the chain rule. So this is the chain rule. Okay. This notation is easy to remember. Okay, because it's called Leibniz notation. So it's easy to remember because you think about this. See, like this two cancel, give you back the dy dx over here, right? Okay. Another notation is this function notation. Okay, so y is a function of u. U is a function of x. Then y here is a function of x. It's a composition of f composed with g. Okay, the outer function is the f. The inner function here is the g. G of x is the u. Okay, so this y here is the composition of f composed with g. Okay. Now the chain rule says that dy dx equal to this. Well, dy dx over here is the duality of this function f composed with g. So when you differentiate this function f composed with g, with this f being the outer function, g being the inner function, then what do we get? Well, dy du, the dy du over here is the same as f prime of u, because f, because y here is a function of u, okay, f of u. Okay, I'm not going to say that word. Okay, so y is a function of u. So dy du is f prime of u. Okay, so dy du is f prime of u. U is equal to g of x. So du dx is g prime of x. The derivative of this u with respect to x. Okay, so du dx here is g prime of x. Now the u over here is equal to g of x, right? U is equal to g of x. So when we replace this u here by g of x, now this chain rule over here we got can be written in this form right here. So this says that if you differentiate the composition of f with g, then you will differentiate this outer function f, and then evaluate at this inner function g, g of x, okay? And then multiply this by the derivative of this inner function g, okay? Now, I'm going to give you more example to explain this, okay? Now, one way for you to, I try to help you to remember this is like, well, composition of function looks like an onion, right? So it has this inner function and outer function, looks like an onion, okay? So when you peel an onion, you start from outside to inside. So you peel the outer layer and then you get to the inner layer, right? So when you differentiate this composition of this f of g, then you would differentiate the outer function first and leaving the inside alone. Okay, so leaving this inside here alone, just leave it there. Okay, and then multiply. Now you get to this inner layer, and then you're going to differentiate this inner function. So times the derivative of the inner function. So it's like a peeling an onion, start from outside to inside. Sometimes the onion has 3 layers, right? So, and then we'll continue that way. So start from outside to inside, okay? Okay, now let's use some example over here. So we're going to differentiate this function over here. This is a composition of 2 functions. Okay, let's think about what's the outer function. What's the outer function? Anyone?
Sine.
The sine function, right? Yes. So we have this outer function is the sine function. And let's think about this. This is the inner function, right? X squared. And the outer function is the sine function. All right, so this is like an onion. Okay, it has 2 layers. So the outer function is y equal to sine of u. And then the inner function is the x squared function. Okay, so the chain rule says that we're going to differentiate the outer function. So we find dy du. What's dy du? What's the derivative of this y with respect to u?
Cosine?
Cosine. Yes, it's cosine. And here is u. Okay, u. Okay. And the u here is x squared. Okay. Now, this is the derivative of the outer function with respect to this u. Okay. So you're leaving the inside alone. So you just keep that x squared in here. Okay. Now we get to the inner function, okay, which is x squared function. Now we're going to differentiate this. Now we're going to differentiate this with respect to x. Okay. The derivative of this with respect to x is 2x. So we just have 2x. Now the chain rule says that dy du is dy du times du dx, right? It's the product of these two, okay? So you just multiply this and this together. So we cosine of, remember leaving this inside function here alone, right? Leaving the inside alone. So x squared over here, cosine x squared, okay? And then multiply with 2x. Now, this one here, if I write it this way, is a little bit ambiguous. Not quite sure is this x squared times 2x first, or you take cosine this first, right? We're supposed to take a cosine x squared first. So to avoid the confusion, so it's better that you put a parenthesis over here. That way, it's making sure that we mean that we take cosine x squared first and then times 2x. Okay, the next one. For this one, the outer function over here is what? Well, the inner function is this sine of x, okay? So the outer function here is u squared, okay? The square function is the outer function. The inner function here is sine of x. All right, now we are going to differentiate the outer function with respect to u, okay? So the derivative of u squared with respect to u is 2u. Now the inner function, sine of x. When we differentiate this with respect to x, what do we get?
Cosine x.
Got it. Good job. Okay, cosine x. Okay. Now by the chain rule, so that will be the product of this times this, right? So we'll have 2 times. Now the u over here is sine of x. So we have 2 sine x multiplied with cosine x. Does it remind you a trig formula? Does it remind you a trig formula?
Sine 2x, is it?
Sine 2x, yes, that's equal to sine of 2x. So that's the double angle formula. So that's the double angle formula. Sine 2x equal to 2 sine x cosine x. Okay, so we simplify it this way. Okay, the next one. This function here is a composition of functions, okay? With the inner function over here being what?
X squared plus 1.
Yes, you got it. So it is x squared plus 1, okay? So the outer function is the square root function. So square root of u. The inner function is x squared plus 1. Okay. So by the chain rule, we're going to differentiate y with respect to u. And down here, we're going to differentiate. Okay. So by chain rule, we're going to differentiate this y with respect to u. Okay. And then later on, we're going to multiply that with the derivative of this inner function with respect to x. Okay. Okay. So what's dy du over here? Hey, remember I told you guys, remember that as a formula, we use it a lot. Do you remember last time? What's the derivative of square root u with respect to u? Anyone? So 1 over
2
2.
times the square root of u.
Square root of u.
Yes, you got it. Okay. Now you remember. That's great. Okay. So remember we went over this. We use the power rule to differentiate, and then we say we can remember it's a formula, right? Okay. Okay. Now, the derivative of this inner function with respect to x is what?
2x.
2x. Yes, that's 2x. So now the derivative of this composition of this outer function with the inner function will be the product of this and this, right? So that will be 1 over 2 square root of, well, the u over here is x squared plus 1. Okay. And then now you multiply this 2x, and then you simplify it. Just in case some of you still don't remember this one, I will put it on the side just to refresh your memory, okay? So over here we have square root of u. That's u to the 1/2 power. So when you differentiate, then we're going to have the derivative of that will be 1/2 u to the negative 1/2 power, because you subtract 1, you get the negative 1/2, which is the same as 1/2 square root of u. So that's how we got it, right? Okay. Now we can remember as a formula. So we don't have to do it over. Yeah, so now we can remember this as a formula. We don't have to do it over and over again. Now, the power rule. So if you u to the n power, when you differentiate with respect to u, that is, what is it? N times
U.
u to the
N minus 1 power.
n minus 1 power. Yes, got it. Good. Okay, now we're going to use it together with the chain rule. Okay, the chain rule we just learned. So y equal to this. Okay, so the outer function over here, what's the outer function, everyone? Y equal to,
U to the 100.
good job, u to the 100. Okay, so let's think about this. It's the inner function u, right? Okay, so u to 100. So the inner function will be x cubed minus 1. Okay, we're going to use the chain rule to differentiate. Okay, now since the outer function is y equal u to the 100 power, think about this as the inner function u. Okay, then the outer function will be u to the 100 power. Then dy du over here will be, now everyone, if you know the answer, just shout it out. So that will be what? 100
Times U.
u to the
99.
99 power, right? Okay. And now the inner function is this. And then we differentiate that with respect to x.
3x squared.
Yes. Okay. So du dx here will be 3x squared. So the chain rule says that the derivative of this y with respect to x will be the product of this one with this one. Okay. So we'll have 100. The u here, remember leaving this inside alone. Okay. So the u here is x cubed minus 1. So leave it there. And now to the 99 power. Multiply with this derivative of the inner function, which is 3x squared. Now you simplify it. Now the next example, number 2. Okay. Now this function over here, we don't use the quotient rule. Okay. Because if actually, there's an easy way that I'm using the quotient rule to differentiate that. Okay. So first, we can ask ourselves, can we rewrite this in power form?
Yes.
Yeah. So it is x squared plus x plus 1 to the what power?
Would be negative 1/3.
Yes, you got it. So we put that in power form. So this will be this to the negative 1/3 power. So the inner function over here will be this. So that will be u. Okay. So the outer function is what?
Oh, the negative 1/3.
U to the negative 1/3 power. Yes, you got it. So the inner function will be x squared plus x plus 1. Now we're going to use the chain rule to differentiate. Now you see I wrote down every step here. Actually, these two are thinking process. In the future, you can actually skip this 2 steps. Okay. So the derivative of this y with respect to u. Okay. What's the duality of this outer function with respect to u? We're going to use what kind of rule? Power rule. Okay, use the power rule to differentiate that. Then we bring down this power in front and then decrease this exponent by 1. So we're going to get negative 1/3. And then u to the
Negative 4/3.
negative 4/3 power. Yes, you got it. Okay. So now the duality of this inner function, du dx, it is 2x plus 1. Okay. So the chain rule says that the duality of the function f here with respect to x is the product of this one and this one. So that we can write it down. Negative 1/3. Now this inner function you just copy x squared plus x plus 1. Now to the negative 4/3 power. Okay. And then multiply. The duality of the inner function here is 2x plus 1. You can rewrite it this way. So you can put negative 2x plus 1 in the numerator. And then you have this 3. Okay. Now because the negative exponent here means reciprocal. So you put this to the 4/3 power in the denominator. Okay. Both of them should be right. Okay. Both these two are equivalent. Okay. I will accept both this one and this one. Okay. But this looks better with positive exponent. Okay. You got it? Okay. Okay, good. Now let's recall the product rule. The product rule says that the duality of f times g is what? Everyone?
The derivative of f times g
Times g, yes, f times g.
plus the derivative of g times f.
Yeah, plus the
F times the derivative of g.
f times g prime. Yeah, f times the derivative g. Yes, you got it. Okay. Okay. Now we're going to use it together with the chain rule. Okay. Now over here, first, it is a product. It's a product of this one with this one. Do we use the product rule first or do we use the chain rule first? Which one do you think we should use first? Product rule first or chain rule?
Product first.
Product rule first because it's a product. Okay, so it's important. It's a product. So we'll use product rule first. So by the product rule, we're going to differentiate the first function. So we're going to differentiate the first function, which is 2x plus 1 to the 5th power. We're going to differentiate that. And then multiply that with the second function. Adding the first function times the duality of the second function. Okay, so that's the product rule. Now, when we differentiate this, what do we get? Well, what kind of rule do I need to use over here? Well, this one over here is, think about this 2x plus 1 here as u, as the inner function. Okay. Then u to the 5th power is the outer function. Okay. So we're going to use the chain rule over here. So we want to use the chain rule to differentiate this function over here. Okay. So first, you see that it's a product. So you use the product rule first. Now when you get to this step, this is a composite of function. So you use the chain rule at this part right here. Okay. Use the chain rule over here. We got the duality of this outer function, u to the 5th power is 5. And then whatever inside, and to the what power? To the 4 power. Yeah. So leaving the inside here alone. Okay, so I just copy it down. So it's 2x plus 1. You just copy over here. Okay, so we're done with the outer. Okay, and then we're going to multiply this with the derivative of the inner. Okay, the derivative of this inner function over here. What's the derivative of this inner function with respect to x?
2.
2. Yeah, so times 2. Now we're done with this. Okay, and then we multiply with this. Okay, now we get to this part right here. Now we're going to differentiate this second function right here, right? Again, think about this here as the inner function. And u to the 4 power as the outer function. Then we're going to use the chain rule to do it because it's a composite of function, compositional function. So we're going to use a chain rule over here. Everyone, okay, tell me. Use the chain rule over here. What do I get? 4 times whatever the inside in the function here is. Okay, so whatever this inside here. Okay, and then to the what power over here?
3.
To the third power, right? Okay, then with the outer, and then we multiply this with the derivative of the inner. Okay, what's the derivative of this inner function?
3x squared plus,
Yes,
minus 1.
we got it. 3x squared here minus 1. That's the derivative of this inner function, right? Now you're done. Okay. Okay, now you just need to simplify this. This is a little bit messy right now. Okay, so 2 times 5, 5 times 2 make 10. So I'm going to put a 10 over here. And then we have 2x plus 1 to the 4 power times this. Okay, and then here you have adding. I have a 4 over here. So 4, 2x plus 1 to the 5th power times 3x squared minus 1 times x cubed minus x plus 1 to the 3rd power. Okay. Okay, so I just simplify it. Okay, so 5 times 2 make 10, and over here I just rearrange the order. Usually, when the expression is the factor is a little bit shorter, I leave it in front. This one has 2 terms, this one has 3 terms, so I leave this 2 terms factor in front of this 3 term factor. Okay, now we can take out common factor. Okay, 10 and 4 has a common factor, which is 2. And what else can we take out? We can also take out this 2x plus 1 to the 4 power and 2x plus 1 to the 5th power has a common factor of 2x plus 1 to the 4 power. Okay, so I'm going to take that out also. And what else? I also have this x cubed minus x plus 1 to the 4 power and this 1 to the 3rd power. So I'm going to go to x cubed minus x plus 1 to the 3rd power. So I take the lower power because it has to be common to both of them. Okay. Now after that, so we use the parenthesis over here. Let's think about after I take out this common factor, what's left for this one. So if I take out 2, I will left with 5 over here. So 5. If I take out this to the 4 power, so it's this one. Yeah, it's this one. So and then for this one, take out this to the 3rd power, I left with one more factor over here, right? So I have x cubed minus x plus 1. Okay. And adding. Now the 4 here, take out 2. I left with 2. Well, this one take out 4 power. I have 2x plus 1. Okay. And then also there's 3x squared minus 1. And this factor is already taken out, so no more this factor here. So now we can just simplify this. So simplify this. Okay, how do you simplify this? You will multiply that in distribute. Over here, you will FOIL this out. Okay, so this, multiply them out. Okay, and combine like 10. And what happened over here is, so this part over here, you're going to, okay, just copy over here. And this part over here, if you simplify it, so it becomes 17x cubed plus 6x squared minus 9x plus 3. Okay, so do the algebra. Okay, all right. So that's how you do it. So after you use product rule here and chain rule here and here, and then you can take out the common factor in front, and you simplify this inside the parentheses. Okay. All right. So that was using the product rule together with the chain rule. Now we go to the quotient rule. Okay. The quotient rule says that if you differentiate the quotient of f with g, that will be f prime times g plus or minus?
Minus.
Minus. Yeah, minus f times g prime. Okay, and then the denominator over here will be g squared. Okay, so that was the quotient rule. Now we're going to use it together with the chain rule. So look at this one. Someone tell me, do I use the chain rule first or do I use the quotient rule first? Which one I use first? This one or this one?
Chain rule?
Yeah. Yes, the chain rule first. Okay. So the quotient rule, you use it when you have, it is a quotient first. And over here, it's not in this quotient form, right? The inside is a quotient, but the whole function here is not in the quotient form. So not, okay? So not this one, okay? Not the quotient rule first. In fact, this one here is in this form. It's a composite function, kind of like an onion, right? The inner function and then the outer function. So it's in this form. Okay, so we use the chain rule first. So we have to distinguish between them. Okay, so this is the in this form. So we'll use the chain rule first, not the quotient rule. Okay. Now we're going to use the chain rule. So use the chain rule. We got this inside here as the inner function, right? And then as a single variable u to the 9 power. Okay. Now the derivative of the outer function will be what? 9 times whatever inside, and then to the what power?
8th power.
8 power. And then this part inside here, you just copy it inside. Okay. Okay. So that indicator is putting the derivative right here. Okay. And now some of you already mentioned, what kind of rule do I use over here when I differentiate?
Quotient rule?
Yeah. So this one over here, we use the quotient rule because it's a quotient. Okay. All right. Good. Now, the first part over here, we just copy and then times. Okay, let's take care of this. Okay, according to the quotient rule, okay, we're going to differentiate the function on top, which is what? 1, right? Derivative, what's the derivative of this?
Yeah, 1.
It's 1, right? And then we times the function in the denominator, which is 2x plus 1. And then minus. Now the function on top, we just cover. We just copy. So we have x minus 2 times the derivative this function down here, which is 2. So times 2. And then over this, the denominator here to the second power. Right. Now we just need to simplify it. Okay. Let's just take care of the front here first. So that will be 9. And whatever goes to the 8 power times So this will be 2x plus 1 minus 2x. Now be careful, here is minus here, okay, big addition. So adding 4 and 2x plus 1 to the second power. Now this 2 will cancel, so that will be 5 on top, right? Then 5 times 9 make 45, so we'll have 45 x minus 2 to the 8th power, and now over 2x plus 1 to the what power? Now this is 2x plus 1 to the 8th power. Now multiply with this 2x plus 1 to the second power. So 8 plus 2 will make 10. So to the 10 power over here. Okay? This is 2x plus 1 to this 8th power times this 2x plus 1 to the second power. So you add this one and this one. So that's how you got this 10 power. Okay? So that was using the chain rule together with the quotient rule. Now the next one. This one here, remember the chain can get longer, okay? So when you have a composite of function, 3 functions like this, then you will use the chain rule like this, okay? So look at this function, okay? The innermost function here is this function, tangent of x. So that's the inner function, innermost function. And the one in the middle is this function cosine over here. And the outermost over here is the sine function. So it's like a 3-layer onion, right? Okay. So we have this, and then this, and then this. Okay. So when we differentiate that, we're going to use what kind of rule? Chain rule, right? So use the chain rule. So we're going to start from the outside. Okay, like peel an onion, we start from the outside and walk to the inside. So duality of the sine function. What's the duality of sine function?
Cosine.
Cosine. So cosine, and then you just leave this inside alone. So you just copy it. So cosine, and then cosine tangent x over here. Okay. Now we're done with the outermost function. Okay, and then times. Now we get to this layer now. Okay, so peel this layer, and now we get to this orange layer. Okay, now we differentiate cosine, right? What's the duality of cosine?
Negative sine.
Yes, it's negative sine. Okay, so that will be negative sine of, and then the inner, this part right here, the inner function, you just leave it there. Okay, so tangent of x over here. So we're done with the middle layer. Now we get to the innermost one, times. What's the duality of this inner function? Tangent x. Remember SST, right? What's the duality of tangent?
Secant squared.
Secant squared, yeah. The duality of tangent is secant times secant, which is secant squared. Okay, so that's secant squared. So remember the trick I shared with you. Do you remember that? So the duality of tangent is secant times secant, which is secant squared. The duality of secant is secant times tangent. Okay, like that. Okay, so go to this. Now this one here will be secant squared x. Okay, now we're done. See, we walk from outside to inside. We peel the outside and then get to the middle and get to the innermost. Okay, now we just need to simplify it. Okay, so to simplify this, what I'm doing over here is just put this negative side in front. That's all. Okay, that's it. Okay, all right. So now this one here is a homework problem. So I'm going to try to help you with this. Okay. So looking at this, what kind of rule do I use first? Now, this part over here, if you regard it as a single variable u, then this will be e to the u, right? So the outer function will be e to the u. Now over here, now you have this 3 data over here. You can think about as a single variable, say v. So secant of v is the middle function. Okay, it's the middle function there. Okay, and then the innermost function will be this 3 data. Okay, so this one here is actually a composite 3 function with this innermost function will be 3 data, and then the middle function over here is the secant of v, and then the outermost function will be e to the u. Okay, so this is a 3-layer onion. Okay, all right. So outer function is e to the u. The middle function is what color is this? Okay, so I use the blue color. So secant of v, and then the inner function here is 3 data, innermost function. Okay, so I explain this step over here. For your homework, you don't need to draw all this diagram because I want to make it clear, so I draw them all out. Okay, so the duality of this function, so differentiate that with respect to u. So remember, this is the differential operator, so which means differentiate this function with respect to u. Differentiate that with respect to u, what do we get? E to the
U.
u. Yeah, you got it. And then now get to the middle one. So we're going to differentiate this with respect to v. And what do we get over here? What's the duality of secant? Remember SST? I hear you. Okay, so that will be secant v times tangent v. Okay, and then the innermost function here is 3 data, and then we differentiate that with respect to data. So that will be 3, right? Okay. Now, by the chain rule, with the duality of y with respect to data is going to be this times this times this. It's better that I leave this constant in front. So it's better that way. So I'm going to put this constant 3 in front. And then e to the secant of 3 data. Okay, times secant v here is 3 data. And then tangent of 3 data. And that's it. Okay. Okay. Question? Okay, we'll get to the last page now. Okay. Okay. So we know that the duality of e to the x is e to the x itself, right? What about a to the x? Where a is a positive constant, say 2. Okay, 2 to the x. What will be the duality, right? Okay, now we're going to try to find out today. Okay. So first, since we know the duality e to the x, I'm going to relate this a to the x here in the form of e to some power. Okay. So notice that a is e to the ln of a. Remember, this exponential function with base e and this log function with base e, they are inverse function. And when they compose, these two cancel and give you back this a over here. So a is e to the ln of a. Okay. So a to the x here, I can replace this a by e to the ln of a. Okay. Now, when you have this to this power and then this whole thing to the x power, what happens is, remember to the power of the power rule, we multiply the exponent right here. Multiply this m with this m. Okay. So we multiply this ln of a with x. So this is going to become e to the x times ln of a. Now this is a composite function. The outer function is what? E to the, think about this part right here as a single variable u, okay? So e to the u. And then the inner function will be x times Ln of a. Okay, that's the inner function. Remember this Ln of a here is a constant because a here is a positive constant. Okay, and then by the over here we're going to use the chain rule. So we're going to differentiate this with respect to u. Then we get e to the u. Okay, differentiate this with respect to x. What do I get? So you have x say times 5, right? And when you differentiate that, then you will get 5, right? So to differentiate this with respect to x, you get Ln of a, that constant there. Okay, so Ln of a. Okay. Okay, so the duality of a to the x will be this one times this one, according to the chain rule. Okay, so it will be e to the x times Ln of a, and then times Ln of a. But I'm going to ask you, do you recognize this part right here? Can this be simplified? What is it? E to the x times Ln of a, e to the x times Ln of a is equal to what? A to the x itself. This is the same as a to the x. So we can replace this by a to the x right here. And now times Ln of a. Now you see that e to the x exponential function e to the x, duality is e to the x itself. The duality a to the x is going to be a to the x itself, but multiplied with Ln of a, Ln of the space. So if it's e to the x, you multiply Ln of e, but Ln of e is equal to 1. So you still get just e to the x, right? Okay. Now let's summarize what we have learned so far. Okay. The duality x to the n is everyone. Okay. So tell me over here. It's what? N times x to the
n minus 1 power.
Yes, you got it. Okay. And then e to the x is
E to the x.
e to the x. You got it. Good. E to the x. Okay. A to the x. Okay. A is a positive constant.
A to the x times ln of a.
You got it. Good. Okay. A to the x times ln of a. Okay. Sine of x.
Cosine of x.
Cosine x. Cosine x.
Oh, negative
Negative
1.
sum.
Negative sine x. Yes. Tangent of x.
Secant squared x.
Secant square x. Yes. Cotangent x. Negative. Negative what? Think about the cofunction of this. What's the cofunction of this? Cosecant, right? So cosecant square of x. Okay. Okay. What about the duality of secant of x?
Secant x times tangent x.
Good job. Secant x times tangent x. Remember our SST trick, right? And then the duality cosecant x. We have a negative sign in front. Now try to think
Negative
about,
cosecant tangent.
yes, think about
times
cofunction.
cotangent.
Yeah, you got it. So cofunction this one and this one. So it will be cosecant, cotangent. Okay. So cosecant x, cotangent x. Okay. So try to remember this. And then we also went over a couple rules. Okay. So the sum and difference rule. Okay. So that will be duality of the sum is the sum of the duality, right? And the duality of the difference is the difference of the duality. And then we also learn about the product rule. So differentiate f times g is f prime g plus f g prime. And then we also learn about this quotient rule. So it will be what? G square in the denominator.
F prime times G minus F times G prime.
F prime times G minus F times G prime. You got it. Now the chain rule. Remember the chain rule now. Okay. So when we differentiate the composition of F of G, okay, that's the composition of two functions. So that will be equal to the duality outer, so F prime. And I'm leaving the inside alone. So just F over here. And then times duality of the inner. So it will be G prime of X. So times, and then times duality of the inner function over here. Okay. All right, we're done with 3.4. This one here, the chain rule is important. You guys did a good job. Okay.